we were looking at the simple diagrammatic representation of the state equation and the output equation uh, of a system which is represented in the form of state variables. Right. Okay. To continue with this, now in the same concept, we bring the linearity as well. Okay. So let us assume that these functional equations represent a linear system. Okay. So linear system indicates that you can obtain the outputs by performing the linear combinations of the input. Correct. At the same time, since the system is assumed to be linear, the states can also be included in such equations. Correct. So this is we assume linear system. So when you say it is a linear system, right, everything can be expressed as a linear combination of systems states as well as inputs. Okay, so I'll write x1 dot is equal to, it's a linear combination, a11 times x1. Okay, x1 I think we wrote capital, right? Okay, let's use the capital here. A11 x1 plus this is a12 x2 plus how many values of x we have? We have n values, so this is a1n into xn. After that we'll start with the u values, inputs. So for inputs we'll give the coefficients b11 times u1 plus b12 u2 dot dot dot. We'll write the last number as this is plus okay, this is m values, right? So I'll write here, so plus b1m b1m into, we can write this as, yeah, so this is b1m um, right, like that. So let's write one more equation. This is x2 dot, this is equal to a21 x1 plus this is a22 x2 plus this is a2n xn plus b21 u1 b22 u2 plus b2m um, right? Very similar to this, we can extend the equations to reach the final one, because there are n number of state variables, correct? So this is xn dot should be equal to an1 x1 plus an2 x2, right? ann xn plus bn1 u1, right, plus b, now this is nm um, right? So for a linear and time invariant systems, right, the coefficients will remain same irrespective of the notation. It's not going to change with the time, right? So for this is linear time invariant systems, any aij comma any bij are the constants. it's not going to vary with the time, right? So directly now we can represent these values in the form of a matrix, right? So this implies we can write x dot of t, it's a time dependent value. A remains constant, a times x of t, because you can see x1 x2 x3 up to xn, so x of t represent that uh, all such values, all right, plus b into this is u of t. So let's try to write them now. What is u of t? U of t is input vector matrix, correct? This is called as input vector matrix. So now the b is called as the uh, matrix of constants which we multiply to the inputs. Okay, so now what is the size of u of t? U of t is actually uh, m rows, 1 columns, right? So in bracket I write this is m cross 1. Now when I talk about the b has to be, it's it's called as input matrix. It's also called as the control matrix. Okay, it's a control matrix. What should be the size? The size is expected to be n cross n. That is the size of the input matrix. Then let's write what is x of t now. So x of t is the state vector matrix, correct? It represents all the states in the form of vector. So this is called as state vector matrix. So what is the size? It's n into 1, n cross 1. Now this A is the last term remaining here. A is called as a system matrix or evolution matrix. Evolution matrix. The size of A is n cross n. It's a square matrix. So that's the first set of equation, right? To calculate the x dot, right? Similarly, if we look at the overall equations of a system, we have the y of t as well, which is the output equation. So this is the state equation, right? We can also rewrite the y of t, that is the output equation, can also be rewritten in the similar format, right? So also the output equations can be written as say we have several outputs, we assumed p number of outputs, right? In the block diagram, if you refer, you can see that we assume, see the output, how many outputs you have, y1 to yp. So we'll use the same notations here. So there are p number of outputs. Let's write one by one. This is y1 of t. This can be assumed to be, let's say, c11. Let's use the c here, right? So c11 into x1, it's a state, right? C11 x1 of t plus c12 c, etc. Like that, we'll use c1n because there are n state variables. So into xn of t, this is fine, correct? Plus it also depends upon the input, right? So this is d11 times u1, d12, etc. Like that we add. So how many values are there? M values are there. So this is d1m into um of t. Equation number 1, right? In the same way, we can extend these equations and write all the equations corresponding to the output, right? So let's write them. Therefore, the last one will write, therefore, yp of t is equal to the coefficient of x1 becomes cp1. cp1 into x1 of t plus this is cpn into xn of t plus what happens to d now? The d becomes dp1. This is dp1 into u1 of t, and the last one becomes dpm into um of t. So these are the equations, right? Again, the system is linear, so most of the linear systems are time invariant. So as we have the time invariant systems present, right? So the Cij and Dij are also constants. Okay, so we'll write Cij, comma Dij. They are the constants. Right. Now we'll try to write these set of equations in the matrix form. Right. Therefore, using matrix form, right, we can try to write it in the following fashion. This is the y of t is the final output, depends upon a matrix of coefficients c into the state variables, that is x of t, plus another matrix of coefficients into the input. Right, here u and x are already known. Y is the output. Y is the output vector. Okay, let's write from D now. So what is D? Let's write. So D is called as direct transmission matrix. It's referred to as the direct transmission matrix. And what is the size? Size has to be P cross M. Okay, the C is called as the output matrix or observation matrix. Or it's also called as the observation matrix. So what is the size of C? C has to be P cross N. Okay, and this Y is nothing but output vector matrix. Output what's the size expected? It has to be, there has to be P elements because P outputs, right? So this is P cross 1. Okay, now therefore the two equations which we are supposed to consider when a state model, right, is the state model is as follows. Therefore, when we say a state model has to be formed, right, for a given system, we need to simply represent the given system in the following format. X, write a x dot of t is equal to a into x of t plus b into u of t. Okay, similarly, write y of t also in the same format, c into the state x of t and another matrix d into u of t. So this is what is called as a state model. First equation is a state equation. The second equation is output equation, right? So writing like this itself is what is the target for us. Okay, now, yeah, so there is one difference when the system becomes time variant. Okay, when the system becomes time variant, A, B, C, D are not constant. As of now, it is constant because we are assuming a time uh, invariant system, right? But when the system becomes time variant, a comma b comma c comma d, all of them become uh, there are no more constants. They are varying with time. So we can write a of t, b of t, c of t, and d of t. Okay, right. So directly we can apply them, and we can try to write the systems equations in the required form. Okay, all right. Let's move further. Now let's try to represent the state variables format for any given questions. We want to bring the equations into this equations of any system uh, to be written in this format, these two formats. Okay, so let's go for a quick problem about that. So the question is like, obtain the state model for the following. The input voltage is Vi of t. There is a resistor R, inductor L, and a capacitor C. And the voltage across capacitor is the output voltage of the circuit. Okay, this is V naught of t. And we assume that there is a current I of t in the given circuit. Okay, now, so we have to observe the number of energy storing elements. That's important. So number of energy storing elements equal to how much in this case? Two, right? There is one inductor and one capacitor. So the I have to decide the number of state variables as well. Correct? So this implies number of state variables. Also, that's equal to 2. Now I have to decide what are those, right? What are those variables? How do we define? So for an inductor, current through an inductor is a variable. Okay. For a capacitor, voltage across a capacitor is the variable. Correct? So let's write them now as follows. So this implies the x1 of t. I'll consider the inductor first. Okay. So this is equal to I of t in this circuit. Similarly, the x2 of t, x2, the second energy storing element is a capacitor for me, correct? And for a capacitor, uh, which is a variable, it's a voltage across a capacitor. In the circuit, voltage across capacitor is represented by V naught, correct? V naught of t. So x has been defined now, capital X has been defined. What is U? What is the input? What is the input to the circuit? Input is a voltage, that is Vi of t. Okay. Now, so I need di by dt somehow, right? Because x1 dot represents di by dt, right? Right? So see, yeah, I want x1 dot. X1 dot mean indicates that it is differentiation of the current. Right. Somehow I need to get the differentiation of the current for this given circuit. Yeah. So the best way to write an equation for I of t is, as we can see, I of t is the current in the first loop. So any equation that you can write relating to a loop is valid. So the best suitable equation is a KVL, right? So let's write KVL to the loop. There is only one loop, right? So apply that. So input voltage is equal to the voltage across each of the device, correct? So yeah, we can write input voltage is Vi of t is equal to, what is the voltage across the resistor? It is R into I of t. Yes, R I. Plus what is the voltage across inductor? It is L times di of t by the dt, plus the voltage across capacitor is V naught of t. Are you fine with that? Yes. Now let me rearrange it only for I of t first, right? This implies, what is the equation for I of t? Every term will go to the left hand side first. So Vi of t, and it gets divided by uh, which one? R, right? R. Okay. So this is how we try to write now. So I of t is, or okay, I think di by dt is directly available, right? I don't have to differentiate, correct? So yeah. Yes, yes, yes. So the differentiated format is directly available. So simply write the di by dt on one side. So I'll write L di of t by dt should be equal to, I'm bringing every term to the other side. Okay, this is Vi of t, which is already there, minus this is R times I of t minus V naught of t. Okay, now let me divide by L. So this is di of t by dt is equal to, this is 1 by L into Vi of t minus this is R by L into I of t minus 1 by L into P naught of t. So normally what I expect is this. So what is di by dt? Di by dt is x1 dot, correct? Yeah. X1 dot of t is equal to, let me compare this. So this implies x1 dot of t is equal to, I'll write the x1 first. X1 is I, correct? I is x1, that's why I write the minus R by L into x1 of t, right? Yeah. Plus 1 by L x2 of t. That is Vi. Yeah. Is it Vi? Sorry, my mistake. It should be V naught, I guess. Should be V naught, right? Yes, V naught. Right. So in that case, I have to change the sign, right? It's not plus, it's minus. Okay, so let's write it in that way. So this is minus. Okay, minus R by L x1 minus 1 by L x2 plus 1 by L into the input, right? So this is U of t, because U of t is Vi. Already we defined them over here. Okay, we are using these notations and we are upgrading the equation. We got x1 dot, right? So similarly, we need the second equation for x2 dot, correct? So in the next step, I'm supposed to get a second set of equation for x2 dot of t, because uh, state variables are two, right? So for both of them, we should write. So yeah, I want, see, the second state variable is V naught. So is there any method to get the differentiation of V naught some, right? So that's my objective now. So what is the equation to what is the equation for V naught? V naught is nothing but voltage across the capacitor. So for voltage across capacitor, we have a standard equation, correct? So also the voltage across the capacitor is, in this case, V naught of t equal to, what is V naught of t? It is 1 by C integral of I of t dt. Right. So let us differentiate. This implies d V naught of t by dt is equal to 1 by C. Now, since the differentiation and integration both happen with respect to the time itself, right? So they cancel because I'm doing d by dt of integral I of t dt. So I'm left with simply I of t. Okay. Now, so this implies dv naught of t by dt itself is x2 dot, correct? So this is x2 dot of t is nothing but 1 by c times, what is I of t? I of t is uh, first first variable, correct? State variable. So I can write this as 1 by c into x1. X1 of t. There is no x2 coming into in this equation. So we'll call this is equation number 2. Right? Now I have to write the equations in such a way that, right? So the first let's write the equation that is corresponding to the state, right? So I just have to write the two equations which we have written just now. So these two equations I want x1 dot and y. So let's try to write that equation. What is x1 dot? X1 dot indicates it is, sorry, x dot indicates x1 dot of t and x2 dot of t should come as an answer. This is equal to, right? I have to multiply, right? I have to check the equation. For the first equation, you just check what are the coefficients of x1 and x2. So x1 has a coefficient minus r by l, x2 has a coefficient minus 1 by l. So those two uh, parameters will come in the first row of the matrix, which is actually the matrix A. Okay, so this is why we are writing like this, because I am writing a matrix here into the x1 and x2, because that is right. X1 of t and x2 of t represents our x of t. X of t is the state, right? State vector. So something into x1 and something into x2 should come. So first element, that is minus r by l, gets multiplied with x1, correct? Whenever we multiply the two matrices, that's the format. So this is minus 1 by l into x2, right? Similarly, look at the second equation and can you tell me what I should write here and what I should write here? Two more variables, two more values I want. So from the second equation, that is x2 dash of t, x2 dot of t, right? It's very clear that I'm multiplying the x2 dot is equal to 1 by c x1 and nothing into x2, correct? 1 by c and 0, that's all. So this value is 1 by c and 0. Okay, I got this. Now I have to check whether I have plus the input part, correct? Because plus I can definitely write something into u of t. So I have to check, is there any u of t coming in? Yes, you see, for the first equation I have 1 by l into that. So only the first equation part will get 1 by l and the second equation becomes 0. So you can observe that this is the matrix A required and this is the matrix B. right? A into x of t plus b into u of t. This is the x dot. X dot is equal to a times x plus b times u. We got it. Okay, first equation is complete. Now, similarly, write the y. Okay, so for writing y, what is y of t? Let's write the equation for y of t. Y of t is equal to, in this case, y of t is simply v naught of t, correct? What is v naught of t? V naught of t is simply x2 of t in this case, isn't it? Right. So in general format, the y of t is written in the following format, right? So the y of t is equal to, now you see, it is just x2 of t. So this is, I multiply 0 into 1, 0 and 1, x1 of t and x2 of t. If I write like this, is it okay? 0 times x1 plus 1 times x2. It's equal to x2 itself, correct? I got x2. Plus, I need a standard format that something into u of t should come, but it should be 0 now. I'm not multiplying with this. 0 into, say, this is u of t. So you can see that this is y. Y is equal to c times, once again, x plus d times u. So this is the matrix D, this is the matrix C for the given question. Now we'll move on to the next question. So obtain the state model for the following circuit is the question. Inductor number 1, inductor number 2, and there is one capacitor over here, and we have one resistor over. This is the given circuit. See, here we have the input voltage E1 of T. This is L1. This is L2. This is the capacitor C with the voltage across capacitor is given as Vc of T. Okay, and there is a current I1. There is another current assumed in this direction, I2. And let's assume that there is a resistor R2 over here, and voltage across this is, output is E naught of T. So this is the given circuit. First, I need to identify, right, what is input, what is output, and what is the number of state variables we have, and what are the names given for the state variables in this question. I just have to identify them. So as we can observe, what is the input? Input is denoted as U of T. In this case, it is EI, correct? I think this is EI, okay, not E1. Please make it change. This is EI of T, right? Input is that, and I need representation for output, and the standard representation is Y of T. But in this case, it is E naught of T, voltage across the resistor R2. Then find out the state variables. So how many energy storing elements you have? Three, right? So therefore, we have three state variables. So totally three state variables. Uh, Let me give this notation. X1 of t, I will consider the first uh, inductor I1 of t. Okay. Then I'll consider the second inductor. X2 of t is I2 of t, the second loop current. Okay, is the current flowing through that inductor, that's why. And x3 of t, the third one is capacitor. So it's already mentioned that voltage across capacitor is VC of t, right? So we have three different state variables that can be identified like this. Okay, now uh, I want you to write the equations corresponding to each of the state variables, like E1 of t or EI of t, what is the equation? VC of t, what is the equation? And how do you obtain the equation number third, that's corresponding to VC of t? So when you apply the equations to equation of the, when you write the equation of the first loop, I think you get E1 of t equals to L1, correct? Uh, L1 into di1 of t by dt, is it right? Yeah. Plus, okay, plus Vc of t, this is right. So you directly get the di1 by dt here itself, right? So this is di1 of t by dt should be equal to, there is E1, there is EI, so 1 by L1 into, do you write E1 of t, correct? And VC goes to other side as a minus, right? So minus 1 by L1 into VC of t. So if I want to represent this in the standard format, what happens to this? This is x1 dot, correct? So x1 dot of t is equal to, we usually write the uh, state variables first. So I prefer writing it in minus 1 by L1 because VC is the state variable. So x3, right? This is x3 plus 1 by L1 times u of t. Can I write it as u of t? Because this is the input, right? So this is equation number 1 for us. So when we write the loop equation for the second one, right? Uh, okay, they have given a sign. You can observe that VC of t has positive uh, for the upper plate of the capacitor and minus for the lower plate. So right, so when you move around the loop in that direction, it is minus to plus, so that is positive. So plus VC of t. Then when you move across the inductor, current moves from left to right, so which indicates it is reducing the voltage. Voltage is being decreased as per our convention, that is negative. Okay, so this is minus L2 uh, into di2 of t by dt. And when I move across the resistor, I'm moving from top to bottom. So current is also moving in the same direction. And you can observe that it is negative because voltage across, as you move across the resistor in that direction, voltage reduces, correct? So this is minus I2 of t into R. So you moved around the loop completely and there is no voltage source. So this is equal to 0. Is your KVL. So when we apply KVL in this fashion, I want to retain that part on the left hand side, which I want to use it as a state variable. That is di2 by dt. I can move it to the other side, correct? So this implies L2 into di2 of t by dt is equal to, keep everything as it is, right? So this is VC of t minus R into I2 of t, right? Now I just want di2 by dt. So dividing by that, this is di2 of t by dt should be equal to, this is 1 by L2 into VC of t minus R by L2 into I2 of t. Okay, that's right. So now this means it is x2 dot, right? This is x2 dot of t equals to, uh, I think we have L3, x3 over there, right? I2 should come first for me. So I'll write the I2 part first. that is minus R by L2. I2 means it is x2, correct? X2 of t. Then I have plus 1 by L2. VC is x3 for us, correct? X3 of t. All right. So the final equation becomes like this. So the third variable we want is x3 dot, right? X3 dot is the differentiation of the voltage across capacitor, dVc by dt, right? So if we try to write the current through a capacitor, we will get the equation directly, right? So what is the current through the capacitor? The current through capacitor in this case is the difference of I1 and I2, correct? And the voltage is already specified over there. So the upper plate has positive, lower plate has negative, which means I1 becomes positive for us, I2 becomes negative for us. I1 minus I2, correct? So I'll write that part now. So therefore, current through capacitor. What is that equation? If you remember, I of t for a capacitor is C into differentiation of 1. So dVc of t by dt in this case, right? This should be equal to, it is difference I1 of t minus I2 of t. Again, this is the right hand side is specific to this problem, right? So what is dVc by dt? I directly get the answer. You see here, this is therefore dVc of t by dt. If you want to calculate, this is nothing but 1 by c times I1 minus 1 by c times I2 of t. All right. So this implies what is this dVc of t by dt? This itself is x3 dot of t should be equal to 1 by c times I1 is x1 minus 1 by c times x2 of t. So we observe that the third equation does not depend upon the input, right? So even though I think the first equation, second equation does not depend on that, but the first equation depends on the input, correct? Right. So we can use equation number 1, equation number 2, and this equation number 3 to write the equation corresponding to the states, right? So that equation, let me write now. So therefore, the x1 comes first, x2, then x3 is equal to, so I just have to refer to the coefficients and I have to write. So first equation says no x1, no x2, but minus 1 by L1 times x3, correct? That's the first. Then the second equation says 0 times this minus R2 by L2 and 1 by L2. Third one says this is 1 by C times I1 minus 1 by C times I2 and 0. Okay, I should multiply this like this. Okay, so this is equal to, sorry, I have to multiply first with x1, x2, and x3, right? So the state variables are considered. I have to look at the inputs as well, right? So only the first equation considers u of t in this thing, right? So this is 1 by L1, I guess. Then others are not considering u. So into u of t. So this is the equation that corresponds to the state variables. So states can be determined by using this. Now, I want to calculate I want to write the equation for output, right? So what is the output of this given problem, right? The output is E naught of t. It's nothing but I2 of t into R, isn't it? So this is this implies the output y of t is simply dependent on x2 of t, r into x2 of t. Correct. So can I write the output now in the following? This implies the y equation, I can write it as C. 0, it depends on x2 as r and it does not depend on x3, right? So, and write the same thing. This is x1, x2, x3, and none of them dependent on the u, so 0 times u of t, right? So I can compare and get the values of C and D matrix like this. So this is matrix A and this is matrix B. So we got all the four matrices, right? So this whole thing is called as the state model of the given problem.